Okay. So, you guys ready? So what I'm gonna have you guys do is, at your table, I want you guys to discuss your answers amongst each other for 5 minutes. See if you guys have. Leilani, can you hear me? She's online. So I know that you and your sister are there, so you guys can discuss it amongst each other as well. Okay, you guys ready? Okay, so first question. Yeah, I can answer. Okay. So he said atoms of different electronegativity share electrons. Does anybody want to add to that? Because that's not quite, what was that? And that's covalent bond. So what you're using the definition, you're using a word in the thing that you're defining to define. You know what I'm saying? Yeah. So that's not a definition. You're not giving me a complete definition. There's stuff missing, but you're close. It's part of it. Yes. Okay. So it's sharing electrons uneven. Okay. Is there anything else that we need to remember about this? Who's going to be able to share electrons uneven? Is it everything on the periodic table can do that, or is it specific? What's that? Non-metals. Okay, what about your definition for ionic bond? Okay, so you said a chemical bond. You guys see it? Because I hard to hear.
That's another.
Answer. Those. Say that one time. From attraction.
Yeah.
Okay, so what do you guys think about that definition? Good? Okay. Is there anything that we should know? Who does that ionic bonding typically? There are exceptions, but for the most part. Who's gonna be doing, was that metals? Metals and non-metals. For the most part, there's an exception, right? So talking about polyatomic diamonds. Okay, so what will be the chemical formula for A? Mg2. What was that? 2 here? What about on an NG?
3.
3. Right, because we know that NG is gonna have a 2 plus charge, and P is gonna have a 3 minus charge, so we can just do that cross multiply thing, and then end up with that. Okay, what, is that a ionic or covalent bond? It's an ionic, so I'm gonna put a big old I over here. Okay, what about? Okay.
6.
Okay. Is that ionic or covalent? Okay, what about the last one? Are you sure? What's that? Sodium. Silicon. Silicide. Okay, and it's what? And it's an ionic bond. What is that rule about using those prefixes? It's only when it's covalent. Yeah. So we use the Greek prefixes for covalent bonds, we don't use it for everything. Okay? Piece of cake. Okay, let's go through the lecture. Before we go through the lecture, we need to talk about your group project. How your group project's coming? Huh? You found a song on the track? So let me give you guys a little more information because I need to give the online crew up information. Even though only one of them shows up to the lecture, you know, so. And then half of them don't watch it. I'm wondering how they're gonna pass this class. I can help you figure that out. There might be some changes because there's a few people who are MIA. So just click that. Okay, so let's start with. Okay, so your group project consists of 4 parts. The first part is going to be your Canvas page, right? Or your parody, I said the parody first, but your Canvas page is going to be your first part. Your Canvas page is going to house everything that you're doing. It's going to house your presentation. It's going to house your, it's all down here. It's going to house your parody, which is your video. It's going to house your presentation, and then it's going to also house information about the course, even though there's things missing here. So I have to fix that. My letters got fucked up. Anyway, so now the rubric for your Canvas page, it's going to be based upon your scientific content. And then this gives you the idea of, what's going to be acceptable. You're going to have to include images. So you need some images to help us work through your stuff. Images or illustrations. It has some clarity, and it has to have some organization. It can't just be pushed together and just all thrown in there. And then you want to make sure that you have all of the other components. You're not missing anything, right? So that's your presentation should be in there. Your parody should be in there. And then the last thing that I want to mention is that you want to make sure that you have your chemical equations and your chemical formatting correctly. That means your superscript and subscript need to be done appropriately. And all of this is done in Canvas. It's going to be in Canvas. You're going to be housing it in Canvas. So if you guys, I'm going to have you guys grab a laptop, because that'll be the easiest way to see it. Anybody have a laptop? Yeah, those who do not have a laptop, grab your laptop. I'm gonna walk you through this process. While that's happening, fix the ones that I see. It's like a pirate moving my nightstand. Yeah. No. Okay, so you guys go into the campus shell. What was that? Say it one more time, please.
Is it kind of like a Wikipedia page?
Yes, it's kind of like a Wikipedia page. Okay, are you guys there? Okay, so. So let's see, share. So do me a favor, if you guys go to groups. So you'll see on the side, let's see. Okay, on the side here, it'll say groups right there. You want to click on that. Okay. you guys should have something that says, it should be a topic in chemistry and it should be a genre of music. Do you guys see that? You don't see that? It's not showing up for you guys? Oh, it's still not, oh, sorry. Yep. On the side. Slide right here. And then set it to right. Okay, now go top. Slide that. Okay, if you go down to where it says people, those are your people. That's your can. People. You just have to do it hard. Everybody. So now go here. Go to groups. Here, let's get you another one. What's happening to some of them yesterday? They haven't created. How's it going? Finally getting there. Okay, so again, you guys need to go to where it says groups, or it has an image of groups. It's like two people together. You're gonna select that. When you select that, then your groups are gonna pop up. So when your group pops up, you're gonna go ahead and click on that one that says, don't just click on the one that says all groups. It'll say a topic and a genre. And then you're gonna go down to people. And then those are your people. Okay, now I can send messages to all my people or an announcement to all my people by hitting announcements. So what I want you guys to do is to send an announcement. Hey, we need to start working on our project. When can you meet? That means do it. Okay. Are you guys able to find it? Okay. So if you guys go to home in your group, if you go in your home in your group, this is where your Canvas informational page will be. To get started with that, actually, why? You want to go to page. You're going to hit add a page. So you're gonna give it a topic, a title. So it's gonna be your page, right? So give it the title for your topic. That would probably be a smart thing to do. What was that? What do you mean by you have to see? Come on, you have it right in front of you, man. Come on. Do you even look at your screen? You're just like, you're gonna make extra work for yourself. Okay, so when you're here, you're able to sit there and type. You can do everything that you can do in any other like database type, not database, word processing type of thing, right? So let's say we're doing a chemical formula. Okay, so we're making methane. And methane is going to be reacting with oxygen. And so my first instinct is just to type it as this, right? But what I need to do is I need to make this superscript or subscript. So I'm going to select my 4. So we can make it bigger. Is that better? I made it too big, but there we go. I'm going to select my 4. Then I'm going to go here. You see where it has the superscript? I'm going to go here and I'm going to select that. And then I'm going to select subscript. And then I need to do the same thing with the oxygen. Then when I want to deselect that, all I have to do is go here. And then I'll deselect it. And so it'll make it back normal. Okay, so now we know that there's an arrow since it's a chemical reaction. So you're going to get your arrow from your equation. So if you go up to the top here, slide over. You see these 3 dots? Those 3 dots mean more. And then this is what shows you what more is. So this symbol here is for equations. Now I need to make it smaller. Okay, so now this will pop up, and then I have choices. So these are just some of the basic ones, but I know I want arrow, so I'm going to go to arrow. And then I select the arrow of my choice. Well, I like this arrow. This is the one that shows that a chemical reaction is yielding to a product. So I'm going to select that, and then I'm going to hit done. Now, once I select that, it'll pop up there. And then I can keep doing what I'm doing. So then I know my products are going to be carbon dioxide and water. So I'm going to fix those subscripts. Okay? Now, I want it to be centered in the page, right? I don't want it to be on the side, because it's important to me. So I like to put it in the center. What I'm gonna do is I'm gonna go back to that line there. And then I'm gonna go up here and I'm gonna center my alignment. So then that'll put it in the center of the page. Okay? Now I want you to play with it. Yes.
Can you show me the arrow again?
No, I want you to figure it out. Talk to each other. That's what you guys are here for. I can't hold your hand to everything, because if I do that, I have to do it for you, then I have to do it for everybody. You guys are grown now. This is college. You guys need to be a little independent. You gotta play with stuff and finish it out. Okay? Figure stuff out. Pardon me? I don't want you to balance it. I don't want you to play with it right now. Not play with the equation. I want you to play with the program. Okay? And I want you to put a chemical equation up there that you can balance. Not my chemical equation, your own chemical equation. You can start with mine and then move to your own. You try? I'm gonna sit my foot through, but it's gonna be a lot of working that out too. I'll share with you as well. Hey, when does that come later? Good. Okay, how's that going for you? Not too bad? Good. Okay, let me show you a couple of other things. So often we have to put links and everything So if we want to link it to something, find a cool link. Oops. Okay, so I got a link. So I'm gonna put a link associated with this reaction. So I'm gonna highlight it. And then I'm gonna select that chain. It's gonna be an external one, so I'm gonna select external. Okay, so now I have a link. So if I go ahead and hit save, and only members can see this and interact with this page right now, you can attach it so that other people, you can say anyone or members. So right now I just have my members that are able to see this. And then I'm gonna go ahead and hit save. So then when I select that link, or select that reaction, it takes me to, you can also add tables. Again, you're gonna go to that 3 dots. Okay, so you can add your table if you need to add tables, and then you're gonna enter whatever you wanna enter there. You can also add media. So movies and videos and everything like that, and so you just upload that media there. Okay, now the rule is you can't use somebody else's video for your parody. You can't use somebody else's video for your presentation. So your presentation is your presentation, right? So you guys need to build your presentation and you guys are gonna present your presentation. There's a tendency that students would try to, and I'll actually make sure I put that in a rubric. Students would try to get out of doing the work by, getting a YouTube personality like Tyler DeWitt or Melissa Maribel, and then they just put their video in there to explain the topic, right? That's not what's happening, right? You need to explain the topic. That's your topic, you're gonna explain it, right? You guys understand? Why are you making that? That face, yes, you understand, that's good, okay. So don't do that. I want you to give the presentation. If I wanted to hear Tyler DeWitt or Melissa Maribel, I would look at them, right? So I want you guys to give the presentations. Okay, so are there any questions? Right? You guys know where to find your everything, and were you guys able to find the assignments? Okay, except for one. I have to put the last one up. So I have it on one site, and I actually have to fix it too. So because when I did proofreading, it cut out words. It was missing every other letter or something like that. Okay. Okay, so let's go ahead and get started for today. You have a question?
What is your budget is the banner and like let's say, the person is assigned a certain topic.
You're
Or is
talking,
it better?
you're talking about group dynamics and group organization, right? So that's what you're asking me. Well, it varies. Sometimes it's not better that way. Sometimes it's better for you guys to get together and work together, you know. But it's just, it depends on the group. You know, some people are really good at doing what they're supposed to do, right? And some of us aren't, right? And so since we know that we have that wide range, right? So sometimes we need to coax people to do the right thing, right? Have you guys ever worked with somebody and you're like, this guy's just the biggest fucking idiot, right? I mean, not trying to be mean, but it's true. You work with somebody who's like that, right? And you know you have to work with them, right? And so there's a couple of ways of dealing with people, right? There's always, I always believe in starting out nice, right? Like with you guys, I was starting out nice, right? You know, friendly and everything like that. And then, you know, and for some people that is very effective, right? It's really good to get them to work. And then some people you gotta bribe, you know, you have to play with their intellect. So it's like sometimes I always tend to have the hardest time getting the smartest people to do work, right? I can tell you about some colleagues of mine. They're brilliant, right? But they won't do shit, right? And so you have to figure out ways to get them to do stuff. Well, food is a great way of bribing them. Hey, let's go. Come on, I'm cooking dinner. Come over, we can work on a project, stuff like that. When I do that, I can get almost half of them to come. If I don't do that, they ain't coming, right? So I know what I can do to sit there and sway certain people. And it's good. It's a good way of, to be a good leader, you always want to sit there and make everybody feel wanted, right? That's a good leader. And that their contribution is going to be valued, right? And in a lot of ways, people don't realize when you have a good team, you build a much better product than when you have a crappy team or one individual doing it, okay? And so you want to try to make sure you get everybody to the table, at least, especially for that beginning part, when you guys are dashing out everything. Get together, figure out what it is. Okay, so you're gonna do this, you're gonna do this, you're gonna do that. And then come back and meet in a couple of days and see what everybody's done. Now, if that person comes and they haven't done anything, that should let you know something, right? That means that either A, you're gonna have to take over, plan on taking over what they're gonna have to do, or B, you gotta figure out what is it that motivates them, right? And then you sit there, you talk to them, hey, come on, you know, sometimes they need you need to help them build up their confidence, right? You're brilliant, we need you, you're really smart on this, we need your insight on this, right? Sometimes you gotta do that, right? You gotta play to their advantage, right? And then you do that, and you get those to come. I can get 2 of the people that I work with to come that way. Man, you're like so smart, we need your brains, right? They show up, right? But if I don't say that, they're not gonna show up, okay? And then I have one that I literally have to yell at. You get your ass there. I'm picking you up. I don't care what you say. I'll be at your door. What time? What time should I be there? I'm not, no, you're coming. I'll pick you up. And I go pick them up. There are those too, right? And so you need to know your teammates. That means you gotta talk to them, right? Get an idea of what they're like. Now, a good leader is gonna be able to do that because everybody's gonna be a little bit different, right? And you guys are practicing being good leaders, right? And so that's part of it. You know, and as a good leader, sometimes you've got to follow, right? You have somebody else that's kind of taking the charge. You've got to give up those reins, you know? I have a student that she was just like, we're doing it, I don't care, blah, blah, blah. And she was just like, this. And nobody wanted to follow her because she was just like, and she would have been a good leader, but she did not want to give up the power at any point. You know, good leaders, you give up the power. You let people take the reins. Hey, work away, girl. You got this. This is your wheelhouse. I'll help you. Tell me what you need help. Tell me what you want me to do, right? And so you've got to be able to do both. If you feel, to me, I find that people that want to control everything, they're insecure with themselves, right? Those micromanagers, they're insecure with themselves. You know, you have to believe in people. You've got to give them an opportunity to shine as well. Everybody wants to shine, okay? But that means that those who don't want to shine, you need to shine. You know, you need to hold up your end of the bargain. You signed up for this class, you signed up to do this job, right? Okay? And you shouldn't expect somebody else to do it for you, right? Okay. Because at the end of the day, you guys get to grade those people, right? That's the fourth thing I hadn't mentioned. You get to grade them on their performance in the group. So each of you guys get to grade each other, including yourself. You should grade yourself, right? And be honest with yourself. If you didn't do shit, you know you didn't do shit. Hey, I deserve that F. Own it, take it, because you did what you did, right? And so you are at that stage to be responsible. So I actually work as, I have many jobs or many hats. So part of my responsibilities this year is I am the president of the CTA for Columbia, for the college, for our faculty. And often we'll get called in by the admin saying, these students said this about this instructor and this about this instructor. And typically what I find is, sometimes it's true. You have these instructors that are just kind of off the chain, they're just like out of control. And so, but it's funny because the ones that are typically off the chains and out of control are the ones that typically don't get as many complaints. And then the ones that actually care about the students, that are really trying to help the students, right? Those are the ones that typically get the complaints because they're passionate about what they do, right? And so a lot of times students will misinterpret passion for they hate me, they dislike me, or she probably has 50 complaints on me already, because I keep calling her out of class, right? And so the thing is that I have to take that into consideration, right? So when I'm making my decisions and how I approach things, I have to take into consideration who that faculty member is, what is it that they've done, and kind of weigh those things. And then of course we have to make sure that we protect them because that's part of my job. I have to protect them, and I have to find the best way of protecting them, right? But I care about the students as well too. I don't want a faculty member who's really mistreating students, that are being abusive to students or anything like that. I don't want that either, right? And so I have to weigh all of those options, and so how I handle what I do, right? And so, but I find there's a tendency when a student is doing bad, right? And they know they're doing bad. They're feeling guilty, right? They're feeling upset with themselves. And their first instinct is to lash out the instructor. The instructor did this, the instructor did this, the instructor did this. I had this kid that came into my class, he joined my class late, because he was moving from one instructor to me, right? And I'm thinking to myself, you think he's me? Oh shit, you're gonna have a field day with me because I don't hold back at all. I let you know, right? And so the thing is that that kid wanted to blame his failures on the instructor rather than taking responsibility for not doing what he's supposed to do, right? Because hey, no instructor is perfect, right? And if they are, they're on crack. They really are. See, I got her attention when I said that, right? So the thing is that there's never going to be the perfect instructor. They're always going to have some type of shortcuts. That's just the way it works. We're human. But you're going to have those that are better than others. Of course, you're always going to have that too. But at one point, regardless if they're the shittiest instructor or the best instructor, if you're really here to do what you're supposed to do, it don't matter. You'll figure out a way to work around it, right? You have to be adaptable. Your education has to be adaptable, right? The best thing to do is when you have that instructor that you feel shitty, talk to them. Hey, I'm a little confused on this. And sometimes you'll get the ones that I can't answer. When they feel like that they can't answer, say, I understand that you're busy and everything like that, but is there any way that you can help me out or lead me to somebody who can help, right? Like a TA or a tutor or something. So that, because, I don't want to take up your time, but I am here to learn and I'm trying to learn, And say it like that because it makes them feel a little bit guilty. And then you'll notice that they'll come around and say, okay, just sit here and, let me help you out, right? And so that is part of that communication. It's reading people and understanding that we are people, right? Instructors are people just like you guys are, right? And so you're going to do that with your group. You need to read your group, right? And that's good leadership. You learn to be great leaders if you learn to read your group. If you don't talk to them, how can you read them? Actually, if you don't talk to them, how can you read them? You can, right? So you guys have to talk to each other and interact with each other, okay? And you'll find that when we do that, the project will be a lot more fun and it'll go by a lot faster. Okay? Questions? Good question. You didn't think you were going to get a lecture on leadership, right? And CTA and all that stuff. Okay. So was this helpful? You guys, I'm feeling really good. I think you guys are gonna handle it. I think you guys are gonna knock it out the park. I am confident in your ability, right? I am so confident in your ability. Now, you guys know that I did tell you at the very beginning of class that for the informational page, you guys can actually use Chat GPT, right? Did I tell you that at the beginning? Yeah? Oh, but that's kind of starting to come back, right? I'm so confident that I know that you guys are going to be able to do it, that I still am going to keep that deal with you guys. Now, the thing is that you guys have to show me the original and what you got out of the original. And then I want you guys to modify that original. You've got to verify. You need to make sure that it's real and not a BS, because ChatGPT has limitations, right? It is an AI, and it's just picking up, the most pervasive topics right now. Currently, put something in and they said, well, we only have data up to 2021. And so it gave me a lot of this bullshit data because they only had data up to 2021. They didn't have the last 2 years, right? And so if they don't have the last 2 years, they're missing a huge part of what I was looking for. So I'm like, well, this isn't gonna help me too much, but it gave me places I can go to sit there and find that information, Because I said, okay, so where do I need to go to find this information? And then it gave me those things, and that's where I started at. And so I was able to fill in those gaps to finish up a report by doing that. So it's a very useful tool, and I want you guys to learn how to use it as a tool. Okay? Any questions? Any other questions? No other questions? Good. So let's go ahead and take a 10-minute break, if that's okay. Then we can start it with work, and then we'll head out. It'll be a short day, sort of. But it should go pretty fast because all we're going to be talking about is nomenclature and bonding. Okay. So last we left off, we were talking about metals, not metals, and metalloids, right? So you guys know the distinction between a metal, a non-metal, and a metalloid. Metals, what are some properties of metals? Chapter 11, we're going to go to 6 and 12 here. Last part of chapter 11. Properties of metals. Anyone, properties of metals. What was that? They're metallic, okay. So what do you mean by that? You're really good at giving the definition within it, yes. Come on, you said it. Tell me what else you mean. What are properties of metals?
I know what I'm trying to say, but I just can't.
What was that?
I know what I want to say, but I can't voice it.
Okay. Look at this metal. Shiny, right? It's lustrous or lustrous, right? So typically metals will have a shine to them, especially if you polish them, right? You polish them to get that nice little shine to it, right? They also are good at doing what? Conductive, yes. Conductive of both electricity and heat, right? Okay, so we also know that they're malleable, right? Your jewelry. What is your jewelry typically made up of? Was that gold? She's a gold, silver, right? Rose gold, fool's gold, right? White gold, okay? So, what was that? It's all gold, yeah. Okay, so those are characteristics of metals, right? And we know that metals on a periodic table, we're able to identify them on the periodic table. Simple, right? Most of the metals start off on the side of the periodic table. Is it the left-hand side or is it the right-hand side? The left-hand side. Okay. So what about non-metals? What are non-metals? Gases. Gases, okay. Liquid liquids. Although we have one metal that's a liquid. Which metal is that? Mercury. Okay.
Solid, but kind of liquid, that's it. It melts the body.
Well, so then that just means it's a solid, but it's going through a phase change, right? So they can also be solid. They're often dull and brittle. So if you guys think about charcoal, charcoal is just carbon, right? So is that shiny? It's really dull and brittle. Can break it off? Okay. So what about metalloids? Metalloids. What are metalloids? Answers in within the name. For ones you can actually use. Part of the name to help define it. What do you think metalloids are? What's that? Has something to do with metal. That's right. That's a good start. It has something to do with metal. So they have characteristics of both metals and non-metals. You know, when things are not quite exactly that, you often put an oil in. You know? So metalloid, you know. Studenoid. That's what I call students that are not quite ready to be students. They're a little bit of a student, but they're not quite there yet. So studenoids. Right? But I don't have any of those here, right? Okay, so these are some of the properties of physical and chemical properties of metals and non-metals. You want to know this. You should know this like the back of your hand, right? Okay, you know where to find them. Your periodic table is so beautiful. It's color coded. It helps you find everything. Outside is a sentence inside. If you don't know how to find a metal on the exam, I'm gonna be very, very disappointed. Okay, now metallic character, right? We've already talked about metallic character. Or we said actually metallic ion character. But in the case of metallic character, we're looking at the characteristics of metal. Which ones are going to be more characteristics of metal? So if you look at the trend on your periodic table, on the left-hand side, we have metals. On the right-hand side, we have non-metals. So it makes sense that the metallic character is going to increase as you go towards the metals, right? Doesn't that make sense? So you're going to be more metal-like as you move this direction. So these guys in the middle, they're metals, but they're less metals than these guys. These are like the real metals, you know? They're like metal, you know? Okay, and then also metallic characteristics is gonna, I guess I should just point to the board for people online. Okay, so as I was saying, as we move from right to left, we become more metallic. And as we move from top to bottom, we also become more metallic, right? So francium is like the metal of all metals, okay? Questions? Concerns? Cash? Kool-Aid? Okay, so that was the last part that we needed to cover in chapters 11. Look at those notes, like that last part especially, because that's going to help you throughout the entire semester. Okay, chapter 12 and 6 and 12. Okay, so you guys already know what a chemical formula is, right? You know what the subscript means, right? What does the subscript mean? How much? Yes. How much of that atom that we have, right? The one that it's right next to. If it's in parentheses, are we talking about just the one that it's next to, or are we talking about everything that's in the parentheses? Okay, good. Okay, so examples is water, H2O, and sodium chloride. So those are both examples of chemical formula. We know that water has 2 hydrogens, 1 oxygen. If there's no number there, it's always understood to be 1, right? And so we always, when there's no when there's no number, we know that that's one. So we never use one physically when we're writing the subscript. Okay? Now we know about how to write the chemical formula for elements. We also know about the diatomic elements. Can you tell me the 7 diatomic elements? And what was the little phrase that I gave to you guys to help you remember? Something about beer. Have no fear of ice cold beer. So tell me my 7 diatomic elements. Hydrogen. Have. Nitrogen. Fluorine. Oxygen. Iodine. Chlorine. And bromine. That is correct. So these are your 7 diatomic elements. You should know this at this point, right? Because we've been talking about it from day 1. We're making that phase. These are your 7. You should know this, right? And so what does that mean? That means when they're all by themselves, they're written as H2 or they're written as O2. So when you're writing those chemical formulas, you need to make sure when we talk about oxygen, you write O2. Does that make sense? Okay, write the formulas for chlorine, argon, bromine, and krypton. Give me the formula for chlorine. Somebody, you guys should be able to do this without CO2, right? What about argon?
AR.
Is it AR2 or is it just AR? Is AR a diatomic element? It's just AR. There we go. Okay, what about bromine? Br2. What about krypton? Kr. It's a little delayed. Okay, so you need to be able to distinguish between diatomic and monoatomic. Monoatomic means what? So almost all the other elements are monoatomic. We do have 2 polyatomic. Do you guys remember what they are? Hey, how are you?
We'll be doing a test on 5 sprinklers. The fire alarms will go off, the sprinklers aren't going to go off.
Okay,
The fire alarms may go off.
okay,
So we're looking at the building.
Okay.
Okay.
okay,
Hopefully it'll be less than 30 seconds.
okay,
And we'll try and do an announcement over the phone as well, okay?
okay, sounds good.
Thank you.
Phosphorus and sulfur. Phosphorus is P4. And sulfur, S8. Those are some good notes. Okay, questions? Concerns? Cash? Kool-Aid? Okay, we can move forward. So just so you guys know, the term is polyatomic. These guys are polyatomic, and that's POLYATOMIC. Polyatomic elements. And they're elements because they only have one type of atom. They only have one type of atom. That makes them an element. Polyatomic. Okay. What was that? Is before. Oh yeah, P4 and S. Yeah, this room, so hard for me to hear. Can I explain what again, please? How I got the 8? Poly? Poly means what? Many, right? And then, so if it's more than 2, it's considered to be poly. If it's 2, it's considered to be di, right? And so that's just the formula for S8. That's just the way it is. It is what it is. There's not a special way that we get it. It was what they determined over time that was the case. I'm gonna have to print out a copy for you. So. I don't have that one. Did I give you guys? I gave you guys chapters 12. It says 12 and
Yeah.
okay. So
You gave 6 and 12, and you gave 6-12.
okay. Which is just a combination. Okay. Okay, so this is just basically showing us where everything is located at. We've gone through this, you've seen this, you know this. And so you guys see that middle part, that's that step ladder right there. So those are going to be our metalloids, right? And so they're semi-metals. They're like metals and non-metals, okay? So they're going to have characteristics of both. Now, when we talk about covalent bonding, we already know that we're sharing electrons, right? And this is just basically showing us, in the case of hydrogen, the hydrogen diatomic element is sharing an electron, right? It's going to share an electron to be like helium. Hydrogen is going to be a unique case. It doesn't want to have 8 around it. It's going to try to be like helium all the time to have 2 around it. Because helium only has 2 valence electrons, right? And that's what hydrogen want to get to, is that 2 valence electrons. Because it doesn't have the space to sit there and keep them all. Okay, so when it shares, you're only going to form a single bond. This here is considered, and I'm pointing to my screen here. Let me show you here. There we go. This here represents a single bond. Okay, questions? There we go. Sorry, my mouse is a little delayed here. Okay, so that is going to represent a single bond sharing of just 1 pair of electrons. Okay, so properties of covalently bonded compounds, they're not going to be able to conduct electricity. So this is water, this is just pure water here, this first one. The second one is sugar and water, right? And then this third one is salt and water. Salt is able to break up into its ionic compounds, its plus and its minus, because the water acts like the home wrecker, it splits them apart, right? And I'll talk about that here in a little bit. Now, when we talk about that sharing of electrons, it's the electron clouds that are overlapping. So that's going to be that sharing part. So you're going to have 2 electron clouds around each of the atoms. They're going to come together, and those electron clouds are going to circle. Those electrons are going to be able to circle both of the nuclei. So that's shown here in this figure. Yeah, see it? So this is one individual hydrogen, this is another individual hydrogen, and when it's bonded together, so that electron cloud is surrounding them both. Okay. So this is an example of fluorine. Now what they're showing here is called the Lewis dot structure. We've talked about the Lewis dot structure in our lab. So let me remind you what the Lewis dot structure is. So if you guys go to your periodic table, the way that you determine the number of valence electrons, the simplest way is trying to beat the alarm so I can get some more stuff in here. Okay, so the simplest way is we're going to be looking at just the s and the p orbitals. So the s is going to be located here. If I can get this to work, come on. There we go. There's my pencil. The s is going to be located here. And the P is going to be located here. So to determine the number of valence electrons, all you need to do is just count the number of electrons that are going to be in your S and your P. So if we have fluorine, fluorine is located right here, right? So then the easiest way of determining it is you count. So that's 1, that's 2, that's 3, 4, 5, 6, 7. Okay, so fluorine has 7 valence electrons. What does that mean? So let me put an F up here. And then we're going to put 7 dots around it.
How did you determine that it is 7?
Do me a favor. Go to the second period. Count all the way up to fluorine. Don't count, just count the S and the P orbitals. This over here, again, is the P. Okay, how many did you count? 7. Okay, so if you're counting only the S and the P orbitals, that's going to give you your number of valence electrons. So that's how we determine what it was. Okay, so this means that we have 7 electrons to work with when we're bonding. So those are the electrons that you can use for bonding. Okay, so fluorine technically has 7 electrons that it can use for bonding. Okay, does that make sense? Now, the goal is when it bonds, it's going to try to get to what we call its octet so that it has 8 around it. Okay, so let me give you an example. Let's say we had fluorine and hydrogen. How many valence electrons does hydrogen have? It has 1. So when it bonds, it's going to go with that fluorine. And it's going to share, that line represents sharing 2 electrons or a pair of electrons. It's going to share 1 pair of electrons with hydrogen. So then hydrogen reaches its octet. It has 2 around it. And then fluorine will have 8 around it. Let me finish drawing my dots here. Draw my dots. Sorry. The computer is just trying to get to my Mac up and running so that I can start using it in class. So. Okay, so remember, the dot the line represents 2 electrons. So that's 2, that's 4, that's 6, that's 8. That would be around that fluorine. Fluorine is going to want to be like a noble gas. All noble gases has 8 electrons in that outer shell, in the S and that P shell. Okay, so, and then hydrogen only wants to be like helium, which only has 2 electrons around it. Okay. Okay, questions?
Like when you draw the dots, is there like a specific way to do it or no?
So there's no specific way. The thing you want to remember is that each it should have 8 around it, if you're getting 8 around it, if your goal is to get the octet. And you want to put them in pairs typically, so you want to pair them up if you can. Or sometimes, like if I have 3, I'll just put 1, 2, 3. So I put 1 here, 1 on top, and 1 on the side. Because you could set it up so you have 1 pair, but usually what happens, it splits up anyway. So I just kind of set them up the way that they're supposed to be. Good question. Okay, let's see. Okay, so this here is just showing you those dots, right? And so if they bond together, they're going to share 1 pair of electrons. And so you're going to get a bond forming between the 2. And so this is how we typically show it with the Lewis dot structure. And then this is how we just show it in general, just a quick way of showing it. Okay, because it's understood that it's reaching the octet. Now, these dots here, those dots are called lone pairs. Lone pairs. So they're called lone pairs is because they're not, in this case, they're not going to be involved in the bonding. They're free. Okay. And so this here represents those lone pairs. There's only one that actually is involved in bonding. It's just the one that's between the 2. So these here would be considered the lone pair. So how many lone pairs does fluorine have around it? It has 3 lone pairs around it. Okay. So again, you're gonna try to obey the octet rule if you couldn't obey the octet rule. There are exceptions to the octet rule, and we'll be talking about that in chapter 13. Okay, we've talked about polar versus non-polar. A polar bond is sharing unevenly, right? Sharing of electrons unevenly. So in that case, when you have 2 atoms that are bonding together and they share unevenly, that's going to be considered polar. And if it's shared evenly, then it's going to be considered non-polar. Now, the next slide shows you a better picture of this. So here, this here is non-polar. So you have 2 atoms that are sharing evenly, right? That just happen to be the same atom. And so in that case, they're sharing evenly. Then the electron is being shared between the 2. They're going back and forth evenly. In the case of polar covalent bond, you can see that the X is getting it less than the Y. So that's the reason the Y is bigger, right? Because it's getting electrons more than the X is. So that would be an uneven sharing. And then here, this is ionic bonding. So you just have the 2 of them interacting because they're charged, but they're independent of each other. So that's part of the reason that they can be broken up by water, where covalent bonds won't be broken up by water. Okay, they won't split them up, okay, because they're actually connected to each other. They're shared. They can react with water, but that compound doesn't be broken up. It won't dissolve in water. Okay, we've talked about the electronegativity already. So the electronegativity is going to be that energy involved to kind of take that electron, have that electron pull it towards you, right? You want it more than the other guy, right? And we know that here's our table. The number that has the highest value, which is fluorine, has the stronger electronegativity. The one that has lower value has a weaker electronegativity. And so we're going to use the differences between the electronegativity to sit there and determine whether or not it's going to be a polar or a non-polar bond. Okay, so I believe on your paper, if you guys have this table in your packet, and it should have does it give you the difference? Let me give it to you. So if the change in electronegativity So, change in electronegativity, delta En, is less than 0.5 it's gonna be non-polar. If it's greater than, but less than, let's say, so. Greater than or equal to 0.5. But it's less than 1.8, it's gonna be polar. Sorry. I was struggling with that. You wanna mention it?
Okay, all right, want to take a minute, if you're interested in, to be a physician, doctor, there's a program available. If you have a specific classes, you can apply. If you're planning to transfer to Fresno State, the, University of San Francisco, and, when they're working with, Fresno State and other, I believe, San Agnes Community, Hospital, and, they provide a pathway to medical school. You start early. If you're interested, let me know. I can share with you a flyer. You can apply. The deadline to apply is October 31st. You need a few classes in. If you're planning to transfer to Fresno State, it would be a great opportunity. Start early. You're going to be exposed to community service. You're going to work with medical students, physicians, nurses. Great experience. Anyone is interested? No?
They all say they wanna be nurses.
Okay. It's better to be a doctor, eh? But if you change your mind, let me know, or Dr. Henry has a flyer. It's a good opportunity. Don't be afraid. Right? Thank you.
You're welcome. Thank you. So we'll talk about that in a second, but, so, we have polar and non-polar, right? So, it's polar is gonna be between the two. And then the last one is called ionic character. Okay, so then that's if it's greater than 1.8. So. Okay. So what does that mean? So what you're gonna do is you're gonna take the electronegativity between two atoms. So let's do carbon and fluorine. Okay. So fluorine has what electronegativity? So we're looking at the between carbon and fluorine. So like C and F. Okay. So we know that it's going to be 4.0. And you always take the one that has that larger value first, and then you subtract the one that has the lower value. So what is carbon? 2.6. So 4 minus 2.6 is going to be what? $1.4. Okay. So then is 1.4, is it less than 5? 1.4 less than 5? No. Is 1.4 between 0.5 and 1.8? Yeah. So then that means it's going to be a polar bond. So between those two, we're going to have a polar bond. So that's all you have to do. Does that make sense? Okay. Everybody got that down? And I would put that on my table as well if it's not already there. But that would be neat. You can tell the weather's starting to change. Everybody has to sniff this. Okay. Okay. So if we have like hydrogen and oxygen, same concept. So in this case, we have 3.4 minus 1.2, and then the difference between them is 1.2. So we know that that would be what? Polar or non-polar? What was that? Are you sure? What is 1.2? Is that between? It's going to be polar because we know it's between 0.5 and 1.8. Thinking about the carbon and the hydrogen, carbon and the oxygen, which is 0.4, and that would be non-polar, right? Okay, questions? Okay, so when we talk about single bonds, double bonds, and triple bonds, well, a single bond is sharing just one pair of electrons. A double bond is sharing 2 pairs of electrons. And a triple bond is sharing 3 pairs of electrons, right? So let me give you an example. Let's say we had oxygen. Oxygen has how many valence electrons? Oxygen has 6 valence electrons. 2, 3. Sorry, my computer is just like freezes up and then wants to act. Gotta bear with my crazy electrons everywhere. If I can get it to. Okay, we're gonna go to the board, otherwise I'm gonna throw it out the window. Okay, so. Okay, so we have oxygen. Oxygen has 6 valence electrons. You guys told me that. Okay, so if I have another oxygen. Now, the goal is to try to get 8 so that 8 is around both of the oxygens, right? So that's a share electron so that there's 8 around both. Okay, so I'm going to show you how to do the first one, and then I want you guys to help me with the next one, right? Okay, so I'm going to take these two, I'm going to put that in the middle. I'm going to take these two and put that in the middle. So then I'm going to end up with. Okay, so then we have pairs of electrons, we draw bonds. Okay, now when we count them, that's 2, that's 4 total, this would be 6, and that would be 8. So this oxygen has a total of 8 electrons around it. All right, let's go see this one. So here, that'll be, let's see that. I'm looking for my funky colors, I can't find my funky colors. Oh, there it is. So then that'll be 2, 4, 6, and 8 around there. Okay, so they both have 8 around there. So then that would be a good start. Right? So we draw this. This is what it looks like. Now this here represents a double bond because we're sharing 2 pairs of electrons. Okay, so this is a double bond. Okay, you know that this here was a single bond because they're only sharing 1 pair. And then if we had nitrogen, nitrogen has how many valence electrons? There's 5 valence electrons. So that's 1, 2, 3, 4, and 5. But 2 nitrogens come together. They're going to have to share, for everybody to have 8 around them, they're going to have to share those 2, these 2, and those 2. So we're going to end up with a triple bond. Okay, because then that's 2, 4, 6, 8 around this nitrogen, 2, 4, 6, 8 around this nitrogen. Okay, so this is the turbine water. Okay, questions?
Good morning. We will be testing our fire alarms this morning. You do not need to exit the building. This is only a test. Thank you.
Was that,
I said, I think we're the ones that's in right there.
are we? Special. Okay, so you can have atoms, you can have bonding between more than one atom, right? So in the case of water, H2O, that's actually a total of 3 atoms that are bonding together, right? And so this just shows you how water is bonding together. And again, you're going to obey the octet rule. This here, okay, so this here shows us the water, and you can see that we're going to obey the octet rule. We have 2, 4, 6, 8 around oxygen. And then here's ammonia. So this would be the Lewis dot structure for ammonia. That's 2, 4, 6, 8 around the nitrogen. And you'll notice that the hydrogens only have 2 around it, right? Because you only have the double bond, the bond between the 2. Not the double bond, the single bond. Okay? How are you guys doing? Good? Okay. So in this case, these guys are going to be exceptions. They're not going to obey the octet rule, right? Meaning that they're not going to allow A to be around them because they're an odd number of electrons. So nitrogen has a total of how many valence electrons? Look at the periodic table, count. It is 5. Okay, so now it doesn't want to behave at all. And then oxygen has how many valence electrons? It has 6. So if we add them together, that's a total of how many valence electrons? I might use my board. How was that work like? Okay, so nitrogen has 5 valence electrons. 2, 3, 4, 5, and then we know oxygen has 6. Okay, so 5 plus 6. That's how many electrons that we have to work with. Now, there is no way in hell that we can get it so that it can have 8 around both of those guys by Shank, right? Because it's an odd number. I usually make a bet and then I take somebody's money, but I won't do that today, I'm not. Okay, so what they have to do is, the one who has the strongest electronegativity will get theirs, right? They will get 8 around them, they'll figure out a way to get 8 around them, and then the one that has the least electronegativity will be short mark. It can't go over, but it can be short mark. So instead of having 8 around it, it'll have 7. Okay, so which one has the stronger electronegativity? Oxygen has a stronger electronegativity. So we want to try to make sure that we have 8 around oxygen, and then we'll have 7 around our nitrogen. So if we do that, we're going to play with it. Over. So then that would give me the 8 around that, but then that would be 2, 4, 5. So let's also bring this in. Okay. So if we do that one. So we have yeah. So you're gonna watch, water's gonna start coming down, that's what I'm saying. All of a sudden, it's gonna be okay. So now the thing that we want to remember is that electrons are mobile, right? And you don't have to get all your electrons, it doesn't have to be shared evenly, right? So one you give up more than the other, right? And that's sometimes what happens. So in this case, we're taking this one from the nitrogen, right? And we're actually putting it between the share between the nitrogen and the oxygen. And we're taking these 2 from the oxygen, we're bringing those over. So then that gives me a double bond, so that's 2, 4, 6, 8 around the oxygen. And then that's 2, 4, 6, 7 around the nitrogen. Okay, now this is an exception to the octet rule. Again, this is an exception to the octet rule. Okay? Okay? Okay. I want you guys to look over the exceptions to the octet rule. That's going to be your next quiz next week. So, exceptions to the octet rule, quiz next week. Okay? And then we'll talk about the rest of this chapter and finish it out. I'll see you guys